Okay, this is 2.5 homework. Problem 1 gives us a fourth degree polynomial, and then they give us a solution, x equals, and it's a complex solution. And it says the equation has two real solutions as well. The smaller one is, and the larger one is. Now I know we could just graph this and find the real solutions. That'd be really, really easy, and that's fine. But on a test, I'm going to check your work to make sure that you can do it without a calculator as well, right? So without a calculator, what we have to do is we know that x minus this 0 is a factor, okay? Because x minus the zeros are always factors of the polynomial. Now, if this complex number is a factor, then so is, or a root, so is this one, x minus, and then the conjugate, 3 plus 2i. So if a complex number is a 0, so is its complex conjugate. All right, now if you FOIL this out, x times x gives you x squared, x times this gives you negative x times 3 plus 2i, and then x times would be the same thing, minus x times 3 minus 2i, and then last times last gives you a positive 3 minus 2i times 3 plus 2i. Alright, so now I can simplify this. I get x squared, and this is minus 3x minus 2xi minus 3x plus 2xi plus, this will be 9. The middle terms are going to cancel with complex conjugates, and then it's minus 4i squared. I squared is negative 1, so that makes 9 plus 4, which is 13. And then the 2xi and the negative 2xi cancel, so I end up with x squared minus 3x plus 13. Minus 6x, I'm sorry, I can add together the negative 3x and negative 3x to get negative 6x. Alright, so there's my quadratic that both of these imaginary or complex solutions come from. Alright, now obviously there's two real roots then, and if I do the division, if I divide this quadratic into this polynomial, that's where I'll get the other two real ones. So let me rearrange this where it's up here so we can still see the problem. Okay, so now we're going to divide our quadratic into our fourth degree. What do I multiply by x squared to get x to the fourth? That would be x squared. Follow through. X squared times negative 6x gives me negative 6x to the third. X squared times 13 gives me 13x squared. Then I'm going to subtract. And those cancel. Negative 9 minus negative 6 is negative 3x cubed. 30 minus 13 gives you 17x squared. I'm going to drop down the minus 33x, and I'm going to start over. Do it again. What do I multiply by x squared to get negative 3x cubed? That would be negative 3x. It gives me negative 3x cubed. Follow through. Gives me positive 18x squared. And then it gives me negative 39x. Need to subtract. And this gives me negative x squared. And this would be negative 33 minus, will be plus 39, which gives you a positive 6x. Now I can drop down the next term, which is minus 13, and do it one last time. What do I multiply by x squared to get negative x squared? That would be minus 1. It gives me negative x squared. Follow through, gives me positive 6x, and gives me negative 13. That's always a good sign when there's no remainder. When I subtract, 0 remainder. So that's my my quadratic that's left over when I divide the other quadratic into it. So basically this fourth degree polynomial is made up of this and this multiplied together. Okay? And I don't need to write that out because all they asked for was the real solutions, which come from this quadratic right here. So I'm going to factor this quadratic into two linear factors. If I can, x minus, I'm not sure. I guess it doesn't factor. Okay. Well, I'm going to use the quadratic formula then. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Double negatives cancel. 9 plus 4 is 13. So here's my two real solutions. So one of them is going to be smaller, so we have 3 plus the square root of 13 over 2 will be the larger one. and 3 minus the square root of 13 over 2 would obviously be the smaller one. So they want the smaller one first, and then they want the larger one. So I would check your work on a problem like this. I realize it's a lot of work, and I can't give you a ton of problems as a result, because this problem would take a while to do all that work. But I will make sure that I hold you accountable for this kind of process, rather than just plugging the. Actually, you know what? Now that I think about it, I don't think you could do this one in the calculator, because those are those are irrational zeros, and you would never be able to give those an exact form. I'm not convinced that Webwork would accept the decimal answer. I'll check that real quick. It does accept the decimal answer, so obviously you could get that right from decimals really easily, but I'll check to see that you did the long division and also did the factor of the complex number. Okay, this problem's somewhat similar to the last one. They give us two of the zeros, they're complex, and then they tell us just to find that polynomial. So if the 0 is 2 plus I, for example, it would be x minus 2 plus I, and then times x minus 2 minus I. And I can just factor that out. So x squared, I have negative x times 2 minus I, and then negative x times 2 plus I, and then positive 2 plus I, 2 minus I. And I just need to simplify this now. Distribute x squared minus 2x plus xi minus 2x minus xi plus 4 minus 2, well, no terms are going to cancel. These are conjugates. Minus I squared, which is negative 1. So the when I go positive, it ends up being 5. And then xi, negative xi cancel, and you end up with x squared minus 4x plus 5. There's my answer right there. So I'll put negative 4 here for me and 5 here. Okay, another similar problem. They give us one of the roots, so we know another one is 1 minus I. And then they want us to find the other two complex roots, so I'm going to have to do the division. So I have to do x minus the 1 plus I and x minus the 1 minus I. I have to FOIL this out, so it'd be x squared minus x times 1 minus I minus x times 1 plus I 1 plus I times 1 minus I, and then do the long division again. So distribute, I get x squared minus x plus xi minus x minus xi plus 1 minus I squared, which is negative 1. Double negatives go positive, so that ends up being 2. And then I end up with x squared, the xi and the negative xi cancel, minus 2x plus 2. I need to find out what the other two ones are, so unfortunately I'm going to have to do the long division again. So I'll erase, actually I'll just carry this down. Hang on a second. Okay, so the division now. What do I multiply by x squared to get x to the 4th? That would be x squared. Now I need to follow through. Negative 2x to the 3rd and plus 2x squared. Now subtract. Gives me negative 4x cubed and 13x squared. I'll drop down the negative 18x and start over. So what do I multiply by x squared to get negative 4x cubed? That'd be negative 4x. And then keep going, follow through. Be positive 8x squared. And then negative 8x, subtract. And you get 5x squared. Negative 18 plus 8 is a negative 10x. Now drop down the 10. And what do I multiply by 2 to get 5x squared? A fraction, great. That might mean I made a mistake, but let's just keep going and find out. So that'd be 5 halves. If I multiply that, that would give me 5. X. Oh, I'm sorry. I'm not looking at this right. This is, if I multiply by 5, I get 5x squared. Okay, there we go. 5x squared, and then negative 10x, and then positive 10. Subtract. and you get no remainder. That's a good sign. Okay, so here is my other quadratic. So this quadratic multiplied by this one gives you this polynomial. These are where the two other zeros come from. We know they're complex, so I'm going to have to use the quadratic formula. So it's opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, this is 16 minus 20, which is negative 4. So I have negative 4 here. This is 2. And then I have 4. So this simplifies to 2i, right? Because it's negative 1. The square root of negative 1 is I. And the square root of 4 is 2. I can simplify this, though, to 2 plus or minus I. Those are my two answers right there. 2 plus I and 2 minus I. I realize that's a lot of work and potentially could take a lot of time, but I am going to give you one problem like this on the test where you have to show all this work. Okay, you have to do first the multiplication, then you have to do the long division, and then you have to use the quadratic formula to get a couple other complex zeros.